if you are going to have any kind of a Boolean function, this Boolean function I can able to like minimize with the help of normal Boolean theorems. So far, what are things that we have seen? But what is the drawback here? Based on the applicability, based upon that time, you are going to get certain kind of expressions. Simple thing is, you may get, so trying to solve the expression may be very complex. This is one problem. Or you may get more than one expression sometimes. Right? And that expression is also not the minimum expression. So it may yield to wrong answer. Means what? It is going to take high cost and more size, right? That is the meaning of that, right? So to overcome this drawback, we are moving for another concept called K-maps. So what is the purpose of K-maps? Which is used for to minimize Boolean expression. That's it. Okay, fine. So how this K-maps is going to work? So actually, when you are going to have an expression, try to think if an expression is like this. Basically, I can able to represent a Boolean expression in the form of an expression first, in the form of a function, right? For example, I am trying to take xy bar plus x bar y. Is it a Boolean function? The same thing, can I able to represent in the form of canonical function? Yes or no? So in canonical function, what is the meaning of this one? I need to compulsory define in the form of standard sum of the products or in the form of standard product of the sums. Right? This is another way. Another way is I can go with the Venn diagrams. The another important way is I can go with the truth tables. Right? So if I would like to implement this expression, what is the truth table for this expression? If I am going to have the inputs x and y, your result should be, this is what? X or y. XRY means what? Right? 0 0 as input, 0 1 as input, 1 0 as input, 1 1 as input. Output will be, when both are same, result is 0, and all the remaining cases output will be 1. Right? So meaning that the same expression I am going to represent in this also. Right? So meaning that I can write this one as output as x bar y, this one as x y bar. These two are same. If you try to write this expression in the form of standard sum of the products, is there an extra terminals you are going to get? No, it is already in standard sum of the products, right? Meaning that, how can you say that it is in standard sum of the products? If you take any term, that term should have n variables, right? As I have taken two variables are in some either complement form or in non-complement form, so I can call it as standard sum of the form, right? The same thing, if you would like to define the like Venn diagram, you can able to implement also, right? Fine. So the advantage of K-map is which is used for to minimize the Boolean expression. And how can we minimize this Boolean expression means, when you are going to have the data in the form of truth tables, right? Meaning that it is diagrammatic representation of, I can write one other terminology, diagrammatic representation of a truth table. It is diagrammatic representation of truth table, right? In truth table, what are the values you are going to have? You are going to have Boolean values either 0 or 1, right? So if I am going to represent if I am going to represent ones, can I able to represent zeros? See, if I am going to construct a circuit for ones, can it work for zeros? It won't. If we are going to give this expression something like this, I have constructed circuit like this, right? This circuit is meant for producing the one for certain kind of inputs, right? If I am going to give other than those inputs, is it going to produce output 0 or not? Yes, that is the meaning, right? So meaning that, which is meant for to define the truth tables, which is the diagram representation of truth tables, where this truth table contains zeros or ones. Those zeros or ones are used to represent these K-maps, right? So for example, this truth table condense this data, right? This diagrammatic representation means it will look like a kind of a square representation. A square representation meaning that it is a collection of cells. It is a collection of cells. So how many cells are there for each and every K map? That is what my question.